we've reached our second period on our periodic table, and the first element in the second period is lithium. Well, lithium was discovered as part of a mineral called petalite. And petalite itself was discovered in 1800. And only 17 years later, that component was identified as a new element, which was named lithium. Well, another mineral, which is also a source of lithium, is lepidolite, and presented on this mineral chart as this purplish pinkish mineral. Well, as we continue with other elements, we'll learn that a lot of them are components of different kind of minerals. So we got this mineral chart. Well, back to our lithium. Pure lithium metal is a very soft metal, so soft it could be cut with a knife. It is also a very light metal, so light it floats on water while reacting with water and releasing hydrogen gas. Well, one day we'll make this experiment, but for now, let's get serious about making our lithium atom model. Well, first we need to figure out the number of protons. Remember, protons determine an element. So we're looking at the atomic number, which is, if we look at our legend, which is indicates number of protons. So we got 3 protons. Well, we still have 2 from our helium model, so we grab one more purple sphere, which represents protons on our model, and we'll start adding it to our nucleus at the same time, removing the helium card, because once we add 3rd proton to our atom, it's not helium anymore. Well, it's not lithium yet neither, because we need to figure out number of neutrons and number of electrons, but that's the start for our lithium atom model. Well, for figuring out number of neutrons for lithium, we're going to use the same analogy which we were using for hydrogen and helium. So we're looking at the atomic mass and rounding up to the closest integer, which for lithium it is 7. And we're also going to be using this information, just a reminder that proton is about 1 AMU, same as neutron, and electrons has such a negligible mass that they could be considered close to 0. So having this in mind and looking at our number, we're going to do elemental calculation. So atomic mass 7 minus 3 protons means that we got 4 neutrons. We must have. But let us see what Wikipedia tells us. And it tells naturally occurring lithium is composed of 2 stable isotopes, lithium-6 and lithium-7, where lithium-7 is by far most common isotope, making up about 92.5% of all natural lithium. And by the way, when you see number to the right of element symbol, it means they want to be specific when they talk about specific isotope. So it means for lithium-7, it means they are talking about lithium isotope with atomic mass of 7. So lithium-7, and it's like more or less a general rule for identifying isotopes. Well, so okay, it confirmed we got 4 neutrons for lithium. We got 2, so we need 2 more. And we're gonna grab 2 more orange spheres and add it to our nucleus. All right, nucleus is good. What about electrons? Well, for an atom to be called an atom, it should be neutral, which means number of protons should be equal to number of electrons. We got 3 protons and only 2 electrons from our helium, so we need 1 more electron. The question is where we're gonna put it, because remember, we figured for helium that our first electron shell is full. It can only have 2 electrons, so it means we're gonna put our 3rd electron for lithium on the 2nd electron shell. Well, and now we can put our card up, because now it is an atom lithium model. Well, one more thing, our favorite electron configuration formula. And for lithium, it is 1s2, 2s1. Well, let us see how they came up with it. The first part, as you remember, is this for helium, and it stays. Those 2 electrons stays. So the new part we got is 2s1, which you can actually figure out. 2 stands for 2nd electron shell. We just put our electron on. S means that this electron is in s orbital, and 1 means that we got 1 electron. And these numbers actually corresponds to the information on period. So 2nd electron shell corresponds to the 2nd period, and 1 electron corresponds to the group number first. So, alrighty, now we covered, well, let us cover one more thing, ions. So, remember the definition of ions? It's when an atom loses or gains electrons. Well, we got only 1 electron we can actually lose on the outer shell. So, let us make our lithium atom lose that electron, and once it lost its electron, it's not an atom anymore, it's cation, positively charged ion of lithium. And if you remember our mnemonic for cations, it's, you know, when it's cation means positive, and positive we got because we removed 1 electron, which means we got more protons than electrons. Well, let us put our electron back, so to have our lithium atom model nice and neat, electron configuration formula. Alrighty, voila, that's our lithium atom model.